In this video, I'm going to read the second part of chapter 41, I believe, Thought Experiments. And if you remember, this is from The Code Breaker, Jennifer Doudna, Gene Editing and the Future of the Human Race by Walter Isaacson. And I left off in the last video down here at the part deafness. That raises the question of what attributes should be labeled disabilities. Sharon Duchesneau and Candy McCullough are a lesbian couple who wanted a sperm donor so they could conceive a kid. Both of them are deaf. They consider their deafness to be part of who they are rather than something to be cured, and they wanted a child who would be part of their cultural identity. So they advertised for a sperm donor who was congenitally deaf. They found one, and now they have a deaf child. A story about the couple in the Washington Post caused them to be condemned by some people for inflicting a disability on a child, but they were applauded in the deaf community. Which was the right response? Should they be criticized for making sure their child had a disability, or should they be praised for preserving a subculture that contributes to the diversity and perhaps even the empathy of society? Would it be different if instead of using a deaf sperm donor, the couple had used a pre-implantation diagnosis to select an embryo that had the genetic mutation for deafness? What if the embryo was typical, but they edited it to be deaf? Would that be okay? What if they asked a doctor to punch out the child's eardrums after birth? In some cases, when formulating a moral argument, it helps to do a reversal test. The Harvard philosopher Michael Sandel uses this thought experiment. Suppose a parent comes to a doctor and says, "My child is going to be born deaf, but I want you to do something to make her able to hear." The doctor should try, right? But now suppose a parent says, "My daughter is going to be born able to hear, but I want you to do something to make sure she is born deaf." I think most of us would recoil if the doctor agreed. Our natural instinct is to consider deafness a disability. How do we distinguish between traits that are true disabilities and ones that are disabilities mainly because society is not good at adapting for them? Take the case of the deaf lesbian couple, for example. Some people may consider both the fact they are deaf and the fact they are lesbian as disadvantages. What if they wanted a genetic procedure that would make their child more likely to be straight? Suppose they chose the reverse and wanted to make it more likely their child would be gay. This is a thought experiment. There is no simple gay gene. Likewise, being born black in America could be considered a disadvantage. A single gene, SLC24A5, has a major influence on determining skin color. What if a set of black parents considers their race to be a social handicap and wants to edit that gene to produce light-skinned babies? Such questions prompt us to look at disabilities and ask to what extent they are inherently disabling and to what extent the disadvantage is due to our social constructs and prejudices. The disadvantages from being deaf for a human or any other animal are very real. In contrast, any disadvantages to being gay or black are due to social attitude that can and should be changed. That is why we can make a moral distinction between using genetic techniques to prevent deafness and using these techniques to influence such things as skin color and sexual orientation. Muscles and sports. Now let's do some thought experiments to see if we might want to cross the blurry line between gene editing that is done to treat true disabilities and gene editing that is done to enhance the traits of our children. The MSTN gene produces a protein that curtails the growth of muscles when they reach a normal level. Suppressing the gene takes off the brakes. Researchers have already done this to produce mighty mice and cattle with double muscling. It is what our biohacker Josiah Zahner used to make his kits that produce super frogs, and for the CRISPR he injected into himself. For more on Zahner, you can Google him. Among those interested in these types of gene edits, other than cattle breeders, are athletic directors. Pushy parents who want champion children are sure to follow. Especially by using germline editing, they might produce a whole new breed of athletes with bigger bones and stronger muscles. Add to this mix a rare genetic mutation that was discovered in the Olympic champion skier Eero Montranranta, sorry about that, initially accused of doping, he was found to have a gene that increased his number of red blood cells by more than 25%, which naturally improved his stamina and ability to use oxygen. So what do we say to parents who want to use gene editing to produce bigger, more muscular kids with greater stamina? Ones who can run marathons, break tackles, and bend steel with their bare hands? And what does that do to our concept of athletics? Do we go from admiring the diligence of the athlete to admiring instead the wizardry of their genetic engineers? It's easy to put an asterisk next to the home run tallies of Jose Canseco or Mark McGuire when they admit that they were on steroids. But what do we do if athletes' extra muscles come from genes they were born with? And does it matter if those genes were paid for by their parents rather than bestowed by random natural lottery? The role of sports, at least since the first Olympics in 776 BC, is to celebrate two things: natural talent combined with disciplined effort. Enhancements would shift that balance, making human effort less of a component of victory. Therefore, the achievement becomes a little less praiseworthy and inspiring. There is a whiff of cheating if an athlete succeeds by obtaining some physical advantage through medical engineering. But there's a problem with this fairness argument. Most successful athletes have always been people who happen to have better athletic genes than the rest of us. Personal effort is a component, but it helps to be born with the genes for good muscles, blood, coordination, and other innate advantages. For example, almost every champion runner has what is known as the R allele of the ACTN3 gene. It produces a protein that builds fast-twitch muscle fibers, and it is also associated with improving strength and recovery from muscle injury. Someday, it may be possible to edit this variation of the ACTN3 gene into the DNA of your kids. Would that be unfair? Is it unfair that some kids are born with it naturally? Why is one more unfair than the other? Height. One way to think through the fairness of using gene editing for physical enhancements is by looking at height. A condition called IMAGE, or image syndrome, which severely curtails size, is caused by a mutation in the CDKN1C gene. Should it be permissible to genetically edit out this defect so that these kids will grow to an average height? Most of us would think so. Now let's take the case of parents who just happen to be short. Should they be permitted to edit the genes of their kids so they will grow to average height? If not, what's the moral difference between these two cases? Suppose there was a genetic edit that could add 8 inches to a kid's height. Would it be proper to use it on a boy who would otherwise be under 5 feet tall to turn him into someone of average height? What about using it on a boy who would otherwise be average height to make him 6'5"? A way to wrestle with these questions is by making a distinction between treatments and enhancements. For various traits, height, eyesight, hearing, muscular coordination, and so on, we could use a statistical method to define types of species functioning. A significant variation below that would be defined as a disability. Using that standard, we might approve of treating a kid who would be less than 5 feet tall, but reject the idea of enhancing a kid who would otherwise be of average height. By pondering the question of height, we can make another distinction that is useful: the difference between an absolute improvement and a positional improvement. In the first category are enhancements that are beneficial to you even if everyone else gets them. Imagine there was a way to improve your memory or your resistance to virus infections. You'd be better off with it, even if others got the same enhancement. In fact, as the coronavirus pandemic shows, you would be better off especially if others had that enhancement as well. But the advantages of increased height are more positional. Let's call it the standing on tiptoes problem. You're in the middle of a crowded room. To see what's going on in the front, you stand on your tiptoes. It works. But then everyone else around you tries it. They all get 2 inches higher. Then nobody in the room, including you, sees any better than the people in the front row. Likewise, suppose I'm an average height. If I were enhanced by 8 inches, I'd be way taller than most people, and that could be a benefit to me. But if everyone else got the same 8-inch enhancement I did, then I would get no real benefit. The enhancement wouldn't make me or society as a whole better off, especially given the legroom of airline seats these days. The only sure beneficiaries would be carpenters who specialized in raising door frames. So enhanced height is a positional good, while enhanced resistance to viruses is an absolute good. That doesn't answer the question of whether we should allow genetic enhancements, but as we grope for a set of principles to include in our moral calculus, the distinction does point to a factor we should consider, favoring enhancements that would benefit all of society over those that would give the recipient a positional advantage. Super enhancements and transhumanism. Perhaps some enhancements will gain broad social acceptance. Then what about super enhancements? Should we ever want to engineer traits and capacities that exceed what any human has ever had? The golfer Tiger Woods had laser surgery to improve his eyesight to be even better than 20/20. Might we want our kids to have super eyesight? What about adding the capacity to see infrared light or some new color? DARPA, the Pentagon's research agency, might someday want to create superior soldiers with night vision. They could also imagine an enhancement that allowed human cells to be more resistant to radiation in case of a nuclear attack. Actually, they aren't just imagining that. DARPA already has a project going in conjunction with Doudna's lab to study how to create genetically enhanced soldiers. One odd result of allowing super enhancements could be that children will become like iPhones. A new version will come out every few years with better features and apps. Will children, as they age, feel that they are becoming obsolete, that their eyes don't have the cool triple lens enhancements that are engineered into the latest version of kids? Fortunately, these are questions we can ask for amusement, but not for an answer. It would be up to our grandchildren to figure these out. Psychological disorders. 2 decades after the completion of the Human Genome Project, we still have little understanding of how human psychology is influenced by genetic dispositions. But eventually, we may isolate genes that contribute to a predisposition to schizophrenia, bipolar disorder, severe depression, and other mental challenges. Then we will have to decide whether we should allow or perhaps even encourage parents to make sure that these genes get edited out of their children. Let's pretend to go back in time. If some of the genetic factors predisposing James Watson's son Rufus to schizophrenia could have been edited out, would that have been a good thing? Should we have allowed his parents to make the decision to do that? If you remember, we talked about James Watson. He was one of the 2 individuals that discovered the DNA structure. Watson has no doubt what the answer should be. Of course we should use germline therapy to fix things like schizophrenia that nature got horribly wrong, he says. Doing so would lead to a lot less suffering. Schizophrenia, depression, and bipolar disorder can be brutal, often deadly. No one would want to inflict it on a person or on any person's family. But even if we agree that we want to rid humanity of schizophrenia and similar disorders, we should consider whether there might be some cost to society, even to civilization. Vincent van Gogh had either schizophrenia or bipolar disorder. So did the mathematician John Nash, and are also Charles Manson and John Hinckley. People with bipolar disorder, including Ernest Hemingway, Mariah Carey, Francis Ford Coppola, Carrie Fisher, Graham Greene, Julian Huxley, the eugenicist, Gustav Mahler, Lou Reed, Franz Schubert, Sylvia Plath, Edgar Allan Poe, Jane Pauley, and hundreds of other artists and creators. The number of creative artists with major depressive disorder is in the thousands. A study by schizophrenia research pioneer Nancy Andreasen of 30 prominent contemporary authors showed that 24 had experienced at least one episode of major depression or mood disorder, and 12 were diagnosed with bipolar disorder. To what extent does dealing with mood swings, fantasies, delusions, compulsions, mania, and deep depression help spur in some people creativity and artistry? Is it harder to be a great artist without having some compulsive or even manic traits? Would you cure your own children from being schizophrenic if you knew that if you didn't, he would become a Vincent van Gogh and transform the world of art? Don't forget, Van Gogh committed suicide. At this point in our deliberations, we have to face the potential conflict between what is desired by the individual versus what is good for human civilization. A reduction in mood disorders would be seen as a benefit by most of the afflicted individuals, parents, and families. They would desire it. But does the issue look different when asked from society's vantage point? As we learn to treat mood disorders with drugs and eventually with genetic editing, will we have more happiness but fewer Hemingways? Do we wish to live in a world in which there are no Van Goghs? The question of engineering away mood disorders gets to an even more fundamental question. What is the aim or purpose of life? Is it happiness, contentment, lack of pain, or bad moods? If so, that may be easy. A painless life was engineered by the overlords in Brave New World, who made sure the masses had soma, a drug that enhanced their sense of joy and allowed them to avoid discomfort, sadness, or anger. Suppose we could hook our brains to something the philosopher Robert Nozick called an experience machine, which allowed us to believe that we were hitting home runs and dancing with movie stars and floating in a beautiful bay. It would make us always feel blissful. Would that be desirable? Or does the good life have aims that are deeper? Should the goal be that each person can flourish in a more profound fashion by using talents and traits in a way that is truly fulfilling? If so, would that require authentic experiences, real accomplishments, and true efforts rather than engineered ones? Does the good life entail making a contribution to our community, society, and civilization? Has evolution encoded such goals into human nature? That might entail sacrifice, pain, mental discomforts, and challenges that we would not always choose. Smarts. Now let's deal with the final frontier, the one most promising and frightful, the possibility of improving cognitive skills such as memory, focus, information processing, and perhaps even someday the vaguely defined concept of intelligence. Unlike height, cognitive skills are beneficial in more than just a positional way. If everyone were a bit smarter, it probably would make all of us better off. In fact, even if only a portion of the population becomes smarter, it might benefit everyone in society. Memory may be the first mental improvement we will be able to engineer, and fortunately, it is a less fraught topic than IQ. It has already been improved in mice, such as enhancing the genes for NMDA receptors in nerve cells. In humans, enhancing those genes could help prevent memory loss in old age, but could also enhance memory in younger people as well. Perhaps we will be able to improve our cognitive skills so that we can keep up with the challenges of using our technology wisely. But there's the rub, wisely. Of all the complex components that go into human intelligence, wisdom may be the most elusive. Understanding the genetic components of wisdom may require us to understand consciousness, and I suspect that's not going to happen in this century. In the meantime, we will have to deploy the finite allocation of wisdom that nature has dealt us as we ponder how to use the gene editing techniques that we've discovered. Ingenuity without wisdom is dangerous.